Hello friends, welcome you all in B.Sc Electronic Science class. In this video, we will see Introduction to Digital System. Myself, G. Patil, Department of Electronic Science, KTHM College, Nasik. Here, we will see T.Y.B.Sc, Semester 1st, Advanced Digital System Design. The paper code is EL331 and it is paper 1. The first chapter is digital system. In that, we will see Introduction to Digital Systems. So, let us start. First, we'll overview the syllabus given for this semester. There are total 4 units. The unit first is digital systems. In this unit, we have to study digital system design process, basic design loops, design flow for logic circuits, Mealy and Murray sequential machine models, state machine notations, state equivalence, state reduction, equivalence classes, implication charts, the state reduction of incompletely specified state tables, merger graphs, and the importance of state assignment techniques, state assignment permutations formula, and ASM symbols. The second unit is Verilog hardware description language. In this unit, we have to study the hardware description language and it is Verilog. To the points to be covered, the importance of HDLs, features of Verilog HDL, overview of digital design with Verilog HDL, hierarchical modeling concepts, basic concepts of Verilog. In that, the operators, comments, number specifications, strings, identifiers, and keywords, the data types in Verilog, sim task and compiler directives, modules and ports. The 3-type modeling of Verilog is to be studied. In that, the gate level modeling, gate types, gate delays, data flow modeling. In that, the points to be taken are continuous assignments, delay expression, operators and operands, behavioral modeling, third type of modeling, structured procedures, procedural assignments, timing controls, conditional statements, multi-way branching, loops, and some of the examples of Verilog design are to be taken. In that, the multiplexers, demultiplexers, encoders, decoders, half adder, full adder, subtractor, flip-flop, counter, and shift register. The unit 3 is programmable logic design. In that, various types of PLDs are to be studied. The introduction to PLD, fixed function ICs, ASICs, that is application specific integrated circuits, PLD, ROM as a PLD, SPLD, in that PLA, PAL, GAL, CPLD, and FPGA. The unit 4 is case study. Here, the 4 case studies have to be studied: the traffic light controller, stepper motor sequence generator, vending machine, and tablet filling system. These 4 case studies are to be designed using digital logic. The books recommended in the syllabus are the Digital Logic Applications and Design by John M. Yarbrough, is Cengage Learning India, Thomson. The second is Verilog HDL, a guide to digital design, and this is by Samir Palnitkar, Pearson, second edition. This is a very excellent book to prepare the Verilog hardware description language. The third is Fundamental of Digital Logic with Verilog by Stephen Brown, Tata McGraw-Hill publication. This is also one of the very good book to prepare digital logic, digital systems, and Verilog hardware description language. And the Digital Fundamentals by Floyd Thomas Jane RP of Pearson publication. So these are the reference books student can refer while preparing for this paper. Here we will start with the first unit, the digital system. So let us start the concept of digital system. Digital system, it is a combination of devices designed to manipulate logical information or physical quantities that are represented in digital form. In the earlier class, say FY.B.Sc and SY.B.Sc, we have studied basic digital circuits like combinational circuits, sequential circuits, in that the multiplexers, demultiplexers, encoders, decoders, and in a sequential circuits, registers, counters, various types of flip-flops. If we remember, all these digital circuits works on the digital logic, that is binary 0 and 1. They have logic input or a digital input and gives digital outputs. So these type of circuits are called as digital circuits, and the systems are called as digital systems. Digital systems deals with discrete signals The input and output of this system is two binary values 0 and 1. The various types of digital system we do use in our day-to-day life, like mobile phones, laptop, cameras, washing machines, all these systems, they are work on digital levels, so they are called digital systems. The basic components of digital systems are input and output equipment, memory, control unit, and arithmetic and logic unit. So, what is digital logic? As we know, digital systems works on a digital logic. So, the digital logic is nothing but a representation of signals and sequences of digital circuits to numbers. It is basis for digital computing and provides fundamental understanding of how circuits and hardware communicates within a computer. Types of digital system, as in introduction we said, the combinational circuits and sequential circuits. These are essentially two types of digital systems. First, the combinational circuits. It is a digital circuit whose output at any instant of time depends on present input only. Here we can take the example of logic gates. We have studied various logic gates like AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gates. And we know that the output of these logic circuits depends on present input only. If the present input changes, the output of that circuit get changed according to the input conditions. So in these circuits or devices, the output at any instant of time depends on present input only. Don't bother about the past input conditions. Those conditions are not to be taken care or need not to be taken care in a combinational circuits. So the different logic gates are combined in the combinational circuits. They are purely made of logic gates. The examples of combinational circuits are adder, in that we can take half adder, full adder, subtractor, encoder, decoder, multiplexer, demultiplexer, and etc. All other circuits. Now, the question arises, how to design the combinational circuits. This we have already studied the designing of combinational circuits. Here we just briefly review the combinational circuit designing steps. First is to understand the problem statement, realize how output of circuit depends on inputs, then draw the truth table presenting the input and output conditions that are required in the problem. Once the truth table is prepared, we have to derive minimized expression for the output with respect to inputs. For minimization of Boolean expression, we use K-map techniques. For simplification of Boolean expression, due to the using these simplification technique, we can reduce the number of terms in the output expression so that the complexity of the circuit get reduced. Since the number of terms are reduced, and since the number of gates required to implement the circuit reduces, circuit complexity get reduced, circuit cost is also get reduced. So minimization is important in designing of combinational circuits. Once we get the simplified expression, we draw the logic circuits from those expressions. These are the steps one can follow in designing the combinational circuits. The next is sequential circuits. The sequential circuit is a logic circuit where output depends on present value of input signal as well as sequence of past inputs. There are two types of sequential circuits: synchronous sequential circuits and asynchronous sequential circuits that we know. The examples: counters, registers, flip-flops. Application of sequential circuits. It includes to design the counters, registers, Mealy and Murray sequential circuits. A sequential machine is a mathematical model of a certain type of simple computational structure. If the sequential machine has finite number of states, it is called as finite state machine. This word will come frequently while studying this paper. So student must know what is finite state machine. It is a machine has finite number of states. Sequential machine has a finite number of states. Then it is called as finite state machine. The steps to design the sequential circuits. The first is to draw the state diagram. Once the state diagram is drawn, prepare the state table. The state table will give us number of input states and the excitation states accordingly, or we say the next state values, present state and next state values are given there. Then reduce the possible number of states using proper state reduction method. In case of combinational circuits, there is also the requirement of minimization of Boolean expressions using the various laws of Boolean algebra or K-map technique to reduce the number of terms. Similarly, in case of sequential circuits, the state reduction is important to reduce the number of states so that the circuit complexity get reduced and it becomes simple to implement the sequential state machine. Then after the state reduction, verify the number of flip-flop required to implement the state machine, then choose the type of flip-flop to be used. Once it is derived, it is known, derive the excitation equations using the map or some other simplification method. Derive output function and the flip-flop input functions. Once these input and output functions are obtained, draw the logic diagram or the list of Boolean functions from which the logic diagram can be obtained. So these are the steps we'll have to follow while designing the sequential state machines. Okay, here digital system design process flowchart is shown. What steps to be followed while designing the digital system? They are given in this flowchart. First of all, we need to know the required product and specifications out of that product. Once this is known, first we have to prepare the initial design, and that design has to be simulated using proper simulation technique. Generally, the CAD tools are used. Various CAD tools are available. CAD tools means computer aided design tools with which we can simulate circuit of any complexity level that we should know. Then after simulation, we can check whether the design is correct or not. If we think the design is correct, we get the proper output from that simulation, we can go for prototype implementation. If we feel the design is not correct, some errors are there, go for redesign, again simulate it and try to check the design. If it is correct, implement the prototype, prepare the prototype, the testing of prototype is done, and after that again we have to check whether it meets the specifications we expect from the design or not. If yes, the product is finished, we can go for implementation of that product, and if some error is there, then according to the level of error we can make a correction accordingly. If the error is minor, make the correction the prototype and again implement the prototype, test it and check again for the specifications. If error is major, we'll have to go for redesign and simulate it again and follow all these steps. This is the flow to be followed while designing the digital system. The explanation of flowchart is given in next slide. Just go through it. The flowchart in the slide depicts the typical development process. We assume that the process to develop a product that meets the certain specifications. The product should function properly. It must meet an expected level of performance. The cost should not exceed the given target. The process starts with the product specifications. Fundamental features of product are identified and acceptable method of evaluating the implemented features in the final product is established. The specifications must be close enough to ensure that the developed product meets the general expectations. After a general structure is established, CAD tools are used to work out the details. Many CAD tools are available. What CAD tool does for the programmer? The CAD tools enable designers to simulate the behavior of incredibly complex product. That is the advantage of using the CAD tools. Otherwise, it is very difficult to design the system. Such simulations used to determine whether the obtained design meets the required specifications. If error found, the appropriate changes are to be made in that, and verification of new design repeated through the simulation. When simulation indicates that the design is correct, complete the physical prototype of the product is constructed. Complete physical prototype of the product is constructed. Then the prototype is thoroughly tested for conformance with the specifications. If any error in the testing must be fixed. If error is minor, it can be eliminated by making small corrections directly on the prototype of the product. If error is large, it is necessary to redesign the product and repeat the above steps. When prototype passes all the tests, means successfully designed and it can go for the production. These are the steps which are given in the flowchart. Okay, so next is design flow for digital system. What flows are to be followed, or what steps to be followed for digital system designing? Actually, it is using HDL is given the second unit hardware description language. You have to again study this flowchart. Here we will shortly go through the flowchart. The same thing as there, same thing are given here. The first, design specification. What specifications we require from that system, that must be decided first. Then the system description, behavioral description of the system is done. It's RTL description. RTL means register transfer level description is done in HDL. Then the functional verification and testing is done for that system. If some error is there, you can go for correction in RTL description. If not, then we can go for logic synthesis and timing verification. Then gate level netlist is to be prepared, and after that logic verification and testing is done. If it is having some error, we can make the correction in RTL description and follow all these steps. When it is got correct, floor planning and automatic place and route step is to be followed. Then the physical layout of the system is prepared and layout verification is done. If it has some minor error, we can make the changes in floor planning and automatic place and route level. Again, prepare the physical layout and we can do the layout verification. If the error is major, we can go for RTL description block. Again, make the changes in RTL description and again follow the same step till layout verification get corrected. Once it is done, the implementation of product is done and our cell system is ready for preparation. This is what the design flow for digital system. Thank you.